5.5 is called multiple angle and product to sum formulas. First, we're going to prove some of these double angle identities using information that we already know before. So we were just using some of these sum and difference formulas. I'm going to show you how these formulas are derived from those formulas. So for example, using the formula, one of the formulas that we just used, sine of u plus v equals sine of u cosine b plus cosine u sine b. We're going to prove one of these double angle formulas. Notice that one of the double angle formulas, and I put it on the first page so we can reference it, is also some versions on the next page as well. But I wanted us to kind of look at it at the same time. So for example, this sine of 2 theta up here at the top here, sine of 2 theta. I can manipulate this, for example, to be sine of theta plus theta. What is theta plus theta? Simplified.
2 theta.
2 theta. So we're just manipulating it to use this formula that we used in the previous section. So let's see how it plays out if we use theta for u and theta for v. All right, so that will just be sine of theta, cosine of theta, plus cosine of theta, sine of theta. Is sine times cosine the same as cosine times sine? Yes or no? Is sine theta cosine theta the same exact thing as cosine theta sine theta?
Yes.
Yes, it is. So they are like terms. They are exactly the same thing. So when we add this together, we get sine of 2 theta equals 2. And if you look up back up, sine theta cosine theta. So we just proved one of those identities. All right, let's use another one of those formulas from the previous section. Using cosine of u plus v, which was cosine of u cosine of v, minus sine of u sine of v. Let's see, can we prove the cosine 2 theta double angle identity? So again, that would be cosine of theta plus theta. Again, for both u and v, we're using theta. So this shouldn't be too hard here. Cosine of theta, cosine of theta, minus sine of theta, sine of theta. So that would be cosine of 2 theta. What is cosine theta times cosine theta? Cosine of theta times another cosine theta.
Isn't it cosine squared theta?
Yes. Yep. Cosine squared theta. And likewise, sine theta times sine theta would be sine squared theta. We're not quite there yet. Notice that we go up to the top. The identity is 1 minus 2 sine squared theta. So what formula, one of my favorites, that you think we're going to have to use to get it to look exactly like that?
The first trigonometric identity?
Not that. Which one? I mean, what's my favorite one to trail? That's what I'm saying. What's my favorite one?
Sine squared theta plus cosine squared theta equals 1.
All right, sine squared theta plus cosine squared theta equals 1. Yep, that's one of the Pythagorean identities, right? We're going to use that one. So, for example, let's say we solve for cosine squared theta. So, I'm going to get cosine squared theta on one side by itself. Then that must mean that that equals 1 minus sine squared theta. Right? So if I want to make a substitution here, I can. I know that cosine squared theta is the same as 1 minus sine squared theta. And I also have another minus sine squared theta. So cosine of 2 theta equals, these are like terms here. These are like terms, so we can add them together. That'll be 1 minus 2 sine squared theta, which is another double angle identity. All right. What if we substituted for sine squared theta instead? Let's see what we'll get. So we want to just sine squared theta on one side, then we'll subtract cosine squared theta. So we started here. Rewrite cosine of 2 theta equals cosine of squared theta minus sine squared theta. And we made a substitution not for cosine squared theta this time, but for sine squared theta. Then that'd be 1 minus cosine squared theta on the inside of that. Then that would be cosine of 2 theta equals cosine squared theta minus 1 plus cosine squared theta. We have like terms here. We have 2 cosine squared theta minus 1, which is another identity. Then let's talk about that tan one up here. Tangent of 2 theta. So let's go over to the right over here. All right, using one of our sum and difference formulas, let's use, remember the tan of u plus v1, which is tan of u plus tan of v over 1 minus tan u tan v. We're going to use that one to come up with this tan of 2 theta identity. So again, we're going to say our u and v are theta and theta. So that would be tan of theta plus tan of theta over 1 minus tan theta times tan theta. What is tan theta plus tan theta?
2 tan theta.
2 tan theta. Yep. Then at the bottom we have 1 minus tan theta times tan theta. What is tan theta times another tan theta?
Tan squared theta.
All right. So we just proved that tan of 2 theta equals 2 tan theta over 1 minus tan squared theta. So that's another double angle identity. Now that we've proven some of those, yeah, let's just use it before we go off to the next set of formulas. So it's so many formulas. I'm definitely gonna give you the formula sheet. It's too many formulas to memorize. So again, these are the double angle formulas written this way. Sine 2u equals 2 sine of u times cosine of u. Tan 2u equals 2 tan u over 1 minus tan squared u. Cosine 2u is equal to cosine squared u minus sine squared u, or 2 cosine squared u minus 1, or 1 minus 2 sine squared u. Solving an equation involving a multiple angle. For this one, solve 2 cosine x plus sine 2x equals 0. We're going to use one of these formulas so that we can get this down to a single angle instead of 2x. So let's use one of the double angle formulas to rewrite as a single angle. So for example, sine 2x. Sine 2x. And I'm using x because that's what the problem is saying, sine 2x. I'm going to convert it to x instead of u's. Sine 2u is 2 sine u cosine u. So sine 2x must be 2 sine x cosine x. So we're going to make a substitution for that. So we have 2 cosine x plus, instead of a sine 2x, we're going to put what it equals to, which is 2 sine x cosine x. All right, now we're going to factor out the common factors from both terms. What is common to both of these? What can we pull out? What is in common?
A 2
2 is definitely common. What else?
and cosine x.
Cosine x. All right. Then we're going to put a parenthesis like this, and then we say 2 cosine x times what is 2 cosine x? 2 cosine x times what will give us back that?
1 plus sine x.
Sine x. All right. So we factor, anytime we factor completely, now we set each factor to 0. So we're going to set 2 cosine x equals 0. 1 plus sine x equals 0. Over here, we can divide by 2 to get rid of the 2. Then we say cosine x equals 0. When is cosine 0? When x equals what? On a unit circle, when is cosine 0?
Zero, 1, 0, negative 1.
Okay, so what is the x then? Yep.
Power over 2 and 3 power over 2.
Power 2 and 3 power 2. Notice though, they didn't say in the interval from 0 to 2 pi. So what do we need to do if they don't specify? They only want solutions on the unit circle.
Plus 2n pi.
Correct. Plus 2n pi or plus 2 pi n. However, I've seen it both ways. So Yep, we write it as a general solution. All right, we did that one. Over here, we need to subtract 1 from both sides. That gives us sine x equals -1. So when is sine -1? X equals what? Sine of what equals -1? Sine, the second coordinate.
3 pi over 2.
3 pi over 2. All right. Plus 2n pi. So we got these. We got, oh, these are the same. Y'all see that, right? So you don't have to write that twice. Let me erase that. So this is already included in this answer. All right, so the answers are in this box here. Pi over 2 plus 2n pi, and web sign may say separated by a comma, 3 pi over 2 plus 2n pi. All right. All right, any questions about that one? All right. This one, use the conditions below to find sine 2 theta, cosine 2 theta, and tan 2 theta. This one shows up a lot, right? Cosine theta equals 5 over 13. Then it tells us what quadrant this information is in. So if y'all draw a coordinate axis right now with your unit circle, which quadrant is this in? From 3 pi over 2 to 2 pi, what quadrant is that?
4.
4. All right. Three pi over 2 to 2 pi. All right, we know that cosine is adjacent over hypotenuse. So our adjacent is 5 and our hypotenuse is 13. So let's find what, you tell me what B is then, the missing side length. So you tell me what B is. I'll give you a minute to work on that. Why don't you private chat me what B equals? Private chat me what B equals. All right, I'm glad I asked y'all that. All right, everybody private chat me. So far, who has responded? Derica. Because I thought y'all had that part down. All right. Let's see. Okay. Let me ask this question because I see we hadn't gotten that part down yet. What quadrant are we?
Four.
Okay. Tell me, where are the signs for quadrant 4 for cosine and sine?
Positive, negative.
All right, positive, negative. So for cosine, my answer is going to be positive, right? So definitely, we see that's true. They gave us a positive cosine. If we go to the right, for example, here, we are going a positive direction. But when we go down, that is negative. So the answer should have been negative 12. Do I need to work it out? Or we got it? Got it? Okay. All right. You got to be careful about what quad. That's why they give you this. It seems like irrelevant information, but it actually is important that you know which quadrant, because you need to know what the sign of that answer is supposed to be. All right. So since we know that, we got sine of theta. We know that's opposite over hypotenuse. So what would be sine then? What would be sine of theta?
Negative 12 over 13.
Negative 12 over 13. Okay, tan theta we know is opposite over adjacent. So what would be tan of theta?
Negative 12 over 5.
Correct. All right. All right, so use the conditions below to find sine of 2 theta, cosine 2 theta, and tan 2 theta. So let's go ahead and write out sine of 2 theta. We're going to use one of our formulas. Let's see, sine of 2 theta. Well, our sine of 2 theta is only 2 sine theta times cosine theta. And we said sine theta was negative 12 over 13. And we said cosine theta was 5 over 13. Tell me, how do you multiply all of this together?
Straight across.
All right, what numbers? What numbers straight across, Michaela?
Honestly, you can do all three.
And what numbers are those?
Would you still do 2 times negative 12 and then 2 times 5?
You said 2 twice. So that means you multiply by 4. So,
Oh, 2 times negative 12 times 5.
all right. All right. If it helps for y'all to put a 1 under that, then put a 1 under it. All right. But if it's a whole number, it's understood to be in the numerator. All right. So y'all multiply the numerator together, and what do you get?
Negative 120.
Correct. And what about the denominator? Some of these we're going to start memorizing with this. These formulas. Well, when we square a lot using this formula. So what is 13 times 13?
169.
169. All right, so we're done with that one. All right, so that's sine of 2 theta. We're done with that one. All right, what about cosine of 2 theta? Which formula y'all want to use? I'm going to go with that one, whatever y'all decide. Because how many different double angle formulas are there for cosine 2 theta? If you look on the second page, let me go back up. Y'all may not have this printed. how many different formulas are there for cosine 2 theta for double angle formulas?
3.
3 different versions. Which one do you want to use? Doesn't matter to me. We did all the grunt work already. We just got to plug it in. Which one do you like? The first, second, or third one?
Third one?
Third one? Okay. Okay. Fine with me. 1 minus 2 times sine square theta. Well, we already worked out sine. That's negative 12 over 13. We just got to square it because it's sine squared. So that's 1 minus 2 times. What is negative 12 over 13 squared? Negative 12 over 13 squared. So we squaring the negative 12. We're squaring the 13.
144 over 169.
Great. Then we got to multiply 2 times that. So that's 1 minus, what is 2 times 144 over 169? 2 times. 288
over 169.
over 169. Then we got to subtract 1 minus 288 over 169. So really that's 169 minus 288 over 169. What is that?
Negative 119.
Yes, over 169. All right, done with that one. Still not done because we got to also find tan of 2 theta. So I'm going to have to space down some. Okay. All right, let's look at our formulas again. Tan of 2 theta. Okay, that's pretty clear what we got to use for tan of 2 theta. That's 2 times tan theta over 1 minus tan squared theta. All right, so that's 2 times negative 12 over 5. We already did the grunt work of it, so we just write it, make a substitution. Negative 12 over 5 squared. All right, let's look at the numerator. What is 2 times negative 12 over 5?
Negative 24 over 5.
Correct. Then we have 1 minus it in the denominator. Then we need to square negative 12 over 5. When you square it, what do you get?
144 over 25.
Correct. So that's negative 24 over 5. And then the bottom, that would be 25 minus 144 over 25. So what is 25 minus 144?
119.
119 negative, right? Over 25 equals, all right, that would be negative 24 over 5 divided by negative 119 over 25, which equals negative 24 over 5 times 25 over negative 119. We can cross cancel here. 5 goes in 25 5 times. So negative 24 times 5. Well, it's a negative divided by negative, so we're going to have a positive answer. It's going to be 120 over 119. 120 over 119. All right. Any questions? All right, this problem is just really sort of like proving something using all of our formulas. So you just write it down for the most part. It says rewrite sine of 3x in terms of sine x. When it says in terms of sine x, they want the final answer to have sine x in it some kind of way. Not just sine of 3x, but sine x has to be in the final answer. So the first formula we're going to use is the sum formula. We know we can split up 3x as 2x plus x. So that's already looking like one of those sum formulas we used in the previous section. Which equals, if we say this is u and this is v, we'll follow that formula, sine of u, which is 2x, times cosine of v, which is x, plus cosine of 2x, sine of x. Okay, so that's the sum formula. All right, now let's use the double angle formulas because we just found out that sine 2u equals something. So we're going to go back to our formula for sine of 2u. That's 2 times sine of u cosine u. So sine of 2x would be 2 sine x cosine x. But we got another x attached to that. And then cosine of 2x, cosine of 2x, we're going to use, all right, let's go back. Let's use this one since we're trying to get things down to sine only. Let's use 1 minus 2 sine squared u instead of the other one where it has a cosine in it. Since it said write it in terms of sine, let's just make a substitution for a cosine right here. Cosine of 2x, let's make a substitution. That's the same thing as 1 minus 2 sine squared x times another sine x. So if you write this, you have 2 sine x, you have a cosine x times another cosine x, which is cosine squared x. All right, and if you, this is supposed to be multiplication here. If you distribute this, that's sine x minus 2 sine cube x. All right. Cosine squared x just popped up. Cosine squared x just popped up. Let's use a Pythagorean identity. We know that sine squared x plus cosine squared x equals 1. So cosine squared x must equal 1 minus sine squared x. All right, so if we multiply all this together, we get 2 sine x minus 2 sine of cube x plus sine x minus 2 sine cube x. We have like terms. We got 2 sine x plus a sine x. We also have negative 2 sine cube x minus another 2 sine cube x. 2 sine x times sine x is 3 sine x. And negative 2 sine cube x minus another 2 sine cube x is minus 4 sine cube x. So we got it all, everything down to sines and simplified it. And that's all they wanted there. All right. All right. I'm going to show you how they came up with some of these power reducing formulas. Then we're going to use them. And we'll move on from there. Proving power reducing formulas. All right, recall. So for now, just write it. I don't know if we have time to go over in detail, but we already came up with cosine 2 theta equals 1 minus 2 sine squared theta. If we wanted to solve for sine squared theta here, for this formula, we already went over this and proved it. How can we get sine squared theta by itself on one side? How would you get it by itself on one side? Sine squared theta. So isolate sine squared theta.
I'll add 2 sine squared theta to the left side.
I like it. Add 2 sine squared theta. Add 2 sine squared theta. Then that would be cosine 2 theta plus 2 sine squared theta equals 1. Then you would
subtract cosine 2 theta on both sides.
Yep. Subtract cosine 2 theta. That cancels that out. We get 2 sine squared theta equals 1 minus cosine 2 theta. Then
divide by 2.
Divide by 2. So the point of just doing this is that these formulas are not coming out of thin air. They're just honestly using the same formulas to derive new formulas. So as you can see on the next page, that's actually one of the power producing formulas. Sine squared theta. Okay. Here, that's the first one. All right. So likewise, if we had cosine 2 theta equals 2 cosine squared theta minus 1, we would add 1. So I'm just go through this really quickly since Michaela did that one. That was probably the harder one. So, and then divide by 2. Divide by 2. You get that cosine squared theta equals cosine 2 theta plus 1 over 2. There's another formula. All right. And then the tan one, we know that tan squared theta. And this is how we're going to write this one. What is tan theta equal to in terms of cosine and sine? What is tan, regular tan, theta equal to? Tan. What does tan equal to? Definition. Identity, however you want to say it. What does it equal to? Just plain tan theta. Michaela?
Secant squared minus 1.
Oh, not even that fancy. What's
Sine
the
over
basic sine over cosine? That's the most basic one we learned was sine over cosine. So tan squared theta would actually be sine squared theta over cosine squared theta. All right. So from what we just learned, sine squared theta, if we look up here, sine squared theta is 1 minus cosine 2 theta over 2. And we just learned that cosine squared theta, if we wrote it the other way, is 1 plus cosine 2 theta over 2. So we have a fraction over a fraction. How do you simplify this fraction? This is called a complex fraction. How do you simplify this? What's the easiest way to simplify this fraction over a fraction? All right. I didn't know to cancel the 2's out. All right, because when you flip it, multiply, flip the reciprocal, the 2's will cancel out, leaving us with just 1 minus cosine 2 theta over 1 plus cosine 2 theta. So that's one way to derive tan squared theta, which is the last power reducing formula. All right. We are going to do one example, and then we're going to move on to something else. All right, it says rewrite sine to the 4th power of x in terms of first powers of the cosines of multiple angles in terms of first powers. All right. They don't want to the 4th power. They want to the first power of the cosines. They want to, in the end, we want cosines. But it could be multiple angles like 2x or something like that. But they want it in terms of cosine. So here's one way you could do it. So we have some formulas for sine squared of x. If we squared that, that's the same thing as sine to the 4th power. One of our formulas for sine squared of x is this one right here. We're going to make a substitution. So that's 1 minus cosine 2x over 2. Square that. That's the same thing as like squaring the top part. So I'm going to break it up like this. Square the top and square the bottom. If you square the bottom, that's just 4. But if you square the top, you got to write that out twice like this. That will cause us to FOIL. 1 times 1 is 1. 1 times cosine of 2x is negative cosine of 2x. Then another one. And then last, we have negative times negative. That's positive. Cosine of 2x times another cosine of 2x is cosine squared 2x. In the top here, you have like terms that you can add together. 1 minus 2 cosine 2x minus cosine squared 2x over 4. To be honest, I would actually take this answer right here. They have some more stuff going on here.
How is the cosine squared 2x negative? How did that become negative if it was just positive?
Oh, thank you. Probably plus. Thank you. All right. 1 minus 2 cosine 2x over 4. This right here, cosine squared 2x, we can use one of these formulas. Cosine. We could use this formula right here. But u is 2x now. If u is 2x here, then that becomes 2 times 2x, which is 4x. All right, 1 plus cosine 4x over 2. All right. Let's pull out that 1/4 from the bottom. It could be written 1 minus 2 cosine 2x plus 1 plus cosine 4x over 2. All right, you can keep on going and going on and on. You could now multiply all this, but the original question said to get it down into cosines, and it could be multiple angles. We have already done that. Right now, I'm just making it more simplified. So if I multiply 1/4 times everything, that's 1/4 times 1 is 1/4. 1/4 times 2 is 1/2. 1/4 times this 1/2 right here is 1 over 8. And then again, that's 1 over 8 times cosine of 4x. Okay. But to be honest, here I probably would have taken the answer. I mean, we have already met it, the what they were asking. All right. I'm not going to prove the half angles. I don't think we have time for that. So I'm going to skip proving half angles, angle formulas today. We didn't need to prove them. I just wanted to show you where the angles were coming from. But it's not necessary that we go over how they were derived. These are the half angle formulas. Let me show you one way you could use the half angle formulas. For example, you could use the half angle formulas, and this is obviously not the only way to find the exact value of sine of 105. There are plenty of ways we've done this. But if you wanted to use a half angle formula, meaning it's some u over 2. So we got sine of u over 2. What we could do is let u over 2 equals 105 just to figure out what the u is to plug into the formula. So how do you solve for u here? How do you solve for u?
Multiply 2 on both sides.
All right. So we multiply by 2. It tells us what our u is. 105 times 2 is 210 degrees. So in this formula, again, you will be given all the formulas. We know that this would be sine of 105 degrees equals, okay, this is the most important part here. The sines of sine u over 2 and sine u over 2 depend on the quadrant in which u over 2 lies. So, for example, 105 degrees. What quadrant is that?
2.
All right. Somewhere here, quadrant 2. All right. Is sine negative or positive in this quadrant?
Positive.
All right. So even though they have a plus or minus formula, the plus or minus depends on the quadrant. So because we're talking about sine, we know that it's going to be a positive. So we don't need to put plus or minus. We know it's positive. So the square root of 1 minus cosine, our u is 210 degrees over 2. On our unit circle, what is cosine of 210 degrees on the unit circle? On the unit circle.
Negative square root over 2.
Negative square root of
3 over 2.
3 over 2. So that's square root of 1 plus square root of 3 over 2 over 2. All right, now we really just got to work with fractions again. So 1 plus the square root of 3 over 2, 1 plus the square root of 3 over 2, that's the same thing as 2 plus the square root of 3 over 2 over 2. Okay. And 2 plus the square root of 3 over 2 is the same thing as 2 plus the square root of 3 over 4. When you multiply the reciprocal by the reciprocal, you get 4. And then if you want to break up these radicals like this, numerator has a radical, denominator has a separate radical, then you can get that radical out of the denominator, which we know we must do. Can't have a radical in the denominator. So we have the square root of 2 plus the square root of 3 here. All right, 1, 3, 4. 4 more examples. And we are done with 5.5. All right. Find all solutions. So we're solving again, but again, our answer is going to lie on the unit circle. Find all solutions of 1 plus cosine squared x equals 2 times cosine squared x over 2. So that looks like one of those formulas, half angle formulas we were just talking about. All right. It's a x over 2. So let's rewrite this, and then we're going to throw in what that equals to. So this is the left-hand side. 1 plus cosine squared x equals 2 times, according to the formula for cosine squared x over 2, this is equal to this. So that's what we're going to plug in. All right, that's that plus minus the square root of 1 plus cosine of x over 2 squared. Left side, we're going to just rewrite it back over. Right side, however, let's look at this plus or minus sign. If we square a positive sign, what do we get?
Positive.
What about we square a negative?
Positive.
Positive again. What if we square a radical? What happens?
You get rid of the
the square root term.
Right. And you just left with 1 plus cosine x over 2. The 2's cancel. You have 1 plus cosine squared x equals 1 plus cosine x. What would you do now? Because we got to solve this equation. What would you attempt to do at this point? We've done all the plugging in that we need to do using the formulas. We did all that. How do you solve the equation now? What would you attempt to do? Because sometimes you don't really know. You just make a move and see what happens.
Try to get x on a side by itself.
Well, usually when we have something square, at least we try to move everything to one side. Because we got more than one x, right? We try to move everything to one side. So if you had a quadratic or a trinomial, for example, you're supposed to move everything to one side, set equals 0. So how do we do that? What would you do first to get everything on one side?
Subtract 1.
So if we subtract 1, we get rid of the ones then. Notice a 1 on both sides. Well, we get rid of both of them. They balance each other out, so we can get rid of both of them at the same time. Now we just have cosine squared x equals cosine x. So what will we do now?
Subtract cosine from both sides.
Subtract cosine. We get cosine squared x minus cosine x equals 0. Then what y'all think? Okay. All right, we get everything on one side. So for example, if we got everything on one side, x squared minus x equals 0. What would y'all do with that?
Would you set them both to 0? The x squared?
You can't set both. We haven't gotten there yet.
Factor.
Factor. Yes. What are we factoring? All right. Somewhat other than Michaela. Do you see how
Will
we
it be
factor?
cosine x 1 minus cosine x?
Ooh. Very close. You said cosine x. You mean factor out cosine x?
Yes, ma'am.
All right. Cosine x times something, right? What goes in the parentheses?
Cosine x minus 1.
Cosine x minus 1. Katria, I think you had it backwards. Then you say 1 first.
Yes,
I
ma'am.
don't know. All right, yeah. Cosine x equals 0 or a cosine. So only after we factor can we set things to 0. Cosine x minus 1 equals 0. Okay. This problem, the answers are between 0 and 2 pi, thankfully. So when is cosine 0? When is cosine 0? On the unit circle. X, when x equals power 2. Okay. What else we got?
3 power 2.
3 power 2. Over here, we add 1. When is cosine 1? When? 1?
0.
0. All right. X equals 0. So we got that answer. We got these two answers too. All right. All right. For pi is -1, right? You go to the left. All right. Product to sum formulas. All right, show you how to use those really quickly. Let me move this up. Rewrite the product cosine 5x sine 4x as a sum or difference. Cosine 5x sine. Notice got cosine first, sine. Which one of these formulas you think it resembles the most on the left side? The first one, second one, third one, or fourth one?
Fourth.
Fourth one, okay. Cosine is first, sine is second. So you must be what? What is you? And what is v? What is you and what is v?
Got it?
Yep. Yeah, we just reading them out basically. All we doing is reading them out. Okay, and then v must be
4x.
4x. Okay, so wherever there's a u in this form, we're just gonna pop it in. Wherever's a v in this form, we're just gonna pop it in. All right. So let's rewrite cosine 5x, it says, times sine of 4x equals. Okay, that's our u, that's our v. This formula says 1/2 times sine of u plus v. U is 5x plus 4x minus sine of u minus v. 5x minus 4x. What is 5x plus 4x?
9x.
What is 5x minus 4x?
Sine x.
Just x, yeah. Done with this problem. That's all they wanted. Just using the formula. We're just plugging things in at this point. Write it as a sum or difference. To figure that out, we had to figure out which formula to use, and we used the last one. U plus v minus sine u minus v. Okay. All right. 2 more to go, y'all, and y'all are done with trig class. There's 2 more to go. All right. Sum to product formulas. Find the exact value of cosine of 195 degrees plus cosine of 105 degrees. Again, many ways to find exact values, but this is one formula to find exact value. You can use the sum to product formula. We got to figure out which formula do we need to use for cosine 195 degrees plus cosine of 105 degrees. Do we use the first one, you think? Second one, third one, or fourth one?
Third.
The third one.
Okay, because, we got 2 cosines, and we got a plus sign in the middle. So it must be the third one. What do you think is u? Or what do you want to be u?
195.
Because it doesn't matter. All right, u 195. So we're going to say v is 105. So we're just going to follow the roadmap of this formula right here. So I'm going to go ahead and just put equal over here. That's the left side. Let's write the right side. So that'll be 2 times cosine of what? Just let's write it all out. Over what?
190.
195 degrees. Plus.
105 degrees.
All right. Yes. Times cosine is same thing but subtraction. 195 degrees minus 105 degrees over 2. Okay. What is 195 plus 105?
300.
300 degrees times cosine. What is 195 degrees minus 105 degrees? 90 degrees. What is 300 divided by 2?
150.
150 degrees. What is 90 degrees divided by 2?
45.
Yep. Okay. On our handy dandy unit circle, what is cosine of 150 degrees? Cosine of 150.
Negative square root of 3 over 2.
All right. And cosine of 45 degrees?
Square root of 2 over 2.
Great. All right, let's approach this question. Now, I can simplify something before we get started. Can anybody see something that maybe we can simplify before we multiply everything out? No? Yes? Owen? Michaela? Somebody?
No.
Cancel out the 2.
Oh, yeah. Because it's like, again, if it makes you feel better, just put a 1 under the 2. So, you know, the 2, one of the 2's in the numerator cancels with one of the 2's in the denominator. All right, so what's left over is the square root, negative square root of 3 times the square root of 2. What is that? So what is this times this? Negative square root of 3 times negative square root of 6. Yep. All right, and we only have 1, 2 left in the denominator, so we're just going to put that over 2. And we are done. We can't simplify the square root of 6 because it doesn't contain a perfect square. So we are done with that one. All right. We have made it to the last one. All right. Sine of 5x plus sine of 3x. We got to figure out which one of these formulas, sum to product formulas. Sine of 5x plus sine of 3x.
The first
All
one.
right. The first one. All right. First one. What do you want U to be and what do you want B to be?
U is 5x and B is 3x.
All right. Now notice this one, we're not just simplifying it. So example 8 said find the value. So we're just trying to simplify. Example 9 is saying solve it, meaning what does x equal in the end? So we're going to end up with some different answers. All right, let's go forward. So we're going to use, let me write it out. Use sine of u plus sine of v equals 2 sine of u plus v over 2 times cosine of u minus v over 2. So that means we have 2 sine 5x plus 3x over 2 times cosine of 5x minus 3x over 2 equals 0. All right. 2 times sine of, what is 5x plus 3x over 2?
8x over 2.
All right, okay. 8x over 2. And what about 5x minus 3x?
2x over 2.
All right. Eight x divided by 2?
4x.
4x.
Mm-hmm.
1x or x.
Or x. Mm-hmm. 2's cancel out here. So really, we got it all the way down to we can't really do anything else other than just divide by 2 at this point. So we can just, if we want to go ahead and divide by 2, get rid of that. That's fine. We have sine of 4x times cosine x equals 0. It's in factored form. So at this point, we're going to set each factor to 0. So sine of 4x equals 0 and cosine of x equals 0. Let's go with the easier looking one. When is cosine x? And we got to write in general solutions, it looks like. Yeah. When is cosine x 0? When cosine of what is 0?
Pi over 2.
Pi over 2. Mm-hmm. So we're going to put, to be a general solution though, we're going to put plus 2 pi n or 2n pi. What else? Cosine of what?
3
3
pi over
pi
2.
over 2.
Mm-hmm. 3 pi over 2. Mm-hmm. All right, we got that one. That was the easy one. Got these answers over here. Then this one, sine of 4x equals 0. We did this before. We let u equals 4x for now. And then we decided when is sine of u equals 0. And then we did some extra stuff after that. When is sine 0? When is sine 0?
0.
Okay. U equals 0. I'm going to put plus 2 pi n. When, what else?
Pi.
I.
Why?
You said pi?
Mm-hmm.
I put 2 pi n. All right. But now that we figured that part out, we're going to put our 4x, substitute that 4x back into u. So instead of u equals this, okay, this is just 2 pi n. Let's put 4x equals 2 pi n. Divide by 4. X equals pi over 2n. And then this one, we're going to let 4x equals pi plus 2 pi n. Divide by 4, both sides. X equals pi over 4 plus pi over 2n. All right. And, okay. So, hold on. All right. So, we got this answer, these answers. All right. Let me do a little chart right quick. See what type of answers we are getting. If n equals 0, okay, let's just look at this one here and this one here. If n equals 0 for pi over 2n right here, what would x be if n was 0?
0.
0. What if for this one down here? If n was 0, what would x would be? Power 4 plus power 2n. If
Power
n was 0, power 4. Okay, great. Let's try when n equals 1. So let's just say they wanted all the angles between, the question was not general solution, but what if they wanted all the angles between 0 and 2 pi? This is one way you can get it. You plug in 1. You plug in 1 for this one. What would you get?
pi over
1.
2.
Pi over 2, correct. What about you plug in 1 here? That'll be pi over 4 plus pi over 2. What is that? Pi over 4 plus pi over 2.
Three
Pi
pi over
over
4.
Correct. 3 pi over 4. Right. All right, let's do a couple more. If n was 2, all right, pi over 2 times 2 would be, so for this one, pi over 2 times 2 would be, see how good y'all are with fractions. Pi over 2 times 2.
Pi.
Pi. All right, what about down here? There'll be pi over 4 plus pi. What is pi over 4 plus pi?
5 pi over 4.
Correct. We are still in the unit circle. Okay. N equals 3. If n was 3,
3
pi
pi over 2.
over, very nice. 3 pi over 2. All right. Still in the unit circle. N equals 3 down here. That would be pi over 4 plus 3 pi over 2. What is pi over 4 plus 3 pi over 2?
7 pi over 4.
Very nice. You were good with fractions, I see. All right. We're still in the unit circle. Isn't 7 pi over 4 in the unit circle? Yep. What about n equals 4? Okay. Pi over 2 times 4. Pi over 2 times 4. What is that? All right.
It's 4 pi over 2, but if you reduce it.
Yep. Is what we always reduce, right? And that would be 2 pi. All right. Now, isn't 0 and 2 pi, isn't that like at the same spot? So that's why notice they said in the interval, and some of the questions that in the interval from 0 included, but 2 pi, notice they had a parenthesis. I mean, don't include, because they are the same, really. So we don't want to double up. So really, we're not going to put this one because we already included it for 0. Okay, what about down here? Pi over 4 plus 2 pi. What is that? We already know that's off the grid because it's already 2 pi plus something else. But what is it? Just to get y'all doing some
9 pi
fractions.
over 4.
Correct. And of course, that's definitely over 2 pi. So that's not, if they ask you for x values that are between 0 and 2 pi, you definitely wouldn't put those last two on there. You put all the ones I circled. I just wanted y'all to notice a little pattern though. You started with 0, then it's 1 pi over 4, then it's 2 pi over 4, then it's 3 pi over 4, then it's 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So if y'all kind of notice that, then there is a better way to write the answer. The best way to write the final answer would have been power 4n or power 4n or n power 4, how y'all want to write it, because really you can sum it up more concisely just by putting n power 4. These answers right here will be included in these answers. So this is like the general solution. All right,